Hello everyone, today we are going to solve question number 203, remove linked list elements. In this video, I am going to discuss three methods to solve this question. Let's see them. So, firstly, let's discuss the problem. The problem here is that linked list store the address of only the next element to it, and it does not know how many elements are there after it. Okay, so the main issue here is if I delete some middle element, or a middle node, in that case, we are going to lose the context of all the future elements. Hence, a deletion of a node inside the linked list is a problem. Second, a deletion of head can cause the deletion of whole list. Okay, so these are the two key problems inside this question. Let's discuss the recursive approach to solve this question. This method is going to take a time complexity of open and space complexity of open. The main idea here is that we are going to solve it and ask the recursion for all the other nodes, okay, for other nodes to be solved. Okay, so these are the steps. If node should be removed, then delete it and continue with recursion. Otherwise, keep the node and recursively progress for the remaining list. Okay, and in the end, return the updated head. Okay. So this is going to be visualization part. I have taken a case where you have to delete the head also. Okay. So in terms of deleting head, what you're going to do is first you'll store the future. Next, you will delete current, and then you're going to call delete current, and then you're going to update the head, and then you're going to call recursion for store. Okay. Next, the recursion going to skip 2 because 2 is not the element that we want to delete. So this, it's going to call something like this. So heads next is equal to recursion and head next and value. Okay. So this is going to call this and so on and so forth. It's going to delete the all the 6 from the linked list. Okay. So let's code this method. So I'm going to write a wrapper function. So return solve head comma well. So this function is directly going to give me the answer for this question. So let's node star solve, and this is going to store head and val. Okay. Next, we'll have a base case. Next, we'll handle head. So if head's value equal value, in that case, first thing we'll store future. So it's going to be list node star future is equal to head value. Okay. Next we'll delete current or delete head. So it's going to be delete head. Next we'll call the recursion. So it's going to be recursion call. So return solve future because we stored it, and sorry, it should be heads next, not head val, and we're going to pass value here. Okay. And the other case where this value was not, the heads val is not equal to val in this case, in that case we're directly simply going to do this, where heads next is equal to solve heads next comma val. Okay. So this is going to be this case, and in the end you're going to return head. And the base case for this one is going to be if the head, this recursion reaches to the end of the linked list. So if head equal null, because the end of the linked list points to null. Okay, then you're going to return null. Okay, so that's the code for solve. Let's run this. Okay, let's submit this. So this is going to be recursion part. Let's solve using the dummy approach. Oh, sorry, non-dummy approach. Okay. So now we're going to use no dummy approach or simply an iterative approach to solve this question. Okay. So this method is going to take a time complexity of O(n) and space complexity of O(n). Okay. So what you can see here is that in this given linked list, there is a case where you have to delete head also. And deletion of head is special. Why? Because we have there's no previous node to it. Okay. The previous to it is null. So there's nothing pointing to it. Hence, to delete head, it's challenging because if we directly delete head, we are going to like delete also the address of the second node, hence deleting the whole linked list. Okay. So to simplify the solution, what we are going to do is first, in the initial stage, we are going to remove all the matching nodes from the beginning of the linked list that are that needs to be deleted, and then we are going to proceed for the remaining nodes normally. Okay. So the steps here are going to be first, we are going to handle the deletion of head. First, remove all the matching nodes from the head from the front of the list or at the head. Okay. Once the head is valid, then proceed for the rest of the list normally. And to proceed the rest of the list normally, we are going to follow the three basic steps. Okay. And in the end, you're going to return the updated head. So this is the visualization part where for deletion of this is for the deletion of head case. So basically in this one, what you are going to do is store the future, delete connect the previous, and delete the current. Okay. So this is for the middle case where you can see this is almost the same as head case. Okay. So these are the three steps. First, you'll store the future. Second, you'll update for the previous. Okay. So this previous is not going to point to current, rather it's going to point to store. Next, we'll delete this current. So by deleting this current, it's also going to lose its pointer to next door. Okay. So this is going to be for this iterative approach. Let's go with this one. So first we'll handle head case, head case. Okay. And here I'm going to use a while loop, not if, because there can also be multiple 6 in the starting of the head. Okay. So the deletion of head can be multiple times, hence I'm going to use a while loop. Okay. So while head is not equal to null and head's value equals value. In that case, I'm going to do 3 steps. First, store future. So it's going to be list node star future, or you can say next is equal to heads next. Okay, you might get confused with next. I'm going to write it as forward FWD. Okay. Next, I'm going to delete head. So delete head, simple. Next, I'm going to reconnect so that my current head is going to be forward. Okay. So you can see if I deleted 1, now my new head is going to be 2. Okay. And this 2 is stored in this forward. Okay. This forward stores 2. So head is going to be forward. And this is going to handle a head case, head deletion case basically. Now I'll need 2 pointers to uh, delete from the middle nodes. Okay. One's going to point to previous and second one's going to point to current. So list node star current is equal to head plus node star previous is equal to null pointer. Okay. Now, while current is not equal to null, so this is for the iteration of the whole linked list. Next, if uh, if currents val equal val. In that case, we have to delete. Okay, this is the case we have to delete. So first we'll store. So I'm also same way I'm going to write list node star forward is equal to currents next. Second, I'm going to delete current. So this is going to be delete current. Next, next will update for previous next. Okay, so previous next needs to be updated. Update. Okay, so previous of next is equal to forward. Okay, so what this line is doing is, yeah, I can show you. This line is same as this one. This you can see previous next is equal to store or forward. Okay, this line is doing this part, and in the end you can just update the current is equal to forward. Okay, this is the case, and the else part is where I don't have to delete this current. Then I'm going to update this, shift this previous and current. So previous is equal to current, and current is equal to currents next. Okay, so this is shifting part. Okay, the shifting part, this is going to be update. This is also shifting part where updating the value of the current to forward. Okay, so that should be it. Now let's return it. Okay, so let's run this. Okay, let's submit this. Okay, so we have solved it using no dummy or basically iterative approach. Now we are going to use the dummy approach to solve this question. It's not an optimization, rather it's simplification for our understanding. Okay, let's see that. Now let's see the dummy approach to solve this question, which is the bread and butter of this video. Okay, it's not going to take a lot of time. Okay, it's very simple. So let's see what it is. So this is going to be a same time complexity and space complexity for as of iterative approach. The main thing that you can see here is the idea behind this method is, rather than handling the head as a special case, we are going to make head non-special by adding a node in front of it. Okay, so basically I'll add a node here which is going to make this node same as a deletion from the middle. Okay, so for dummy there's no need to handle head separately. You are going to create a dummy variable and store it in the beginning of the linked list. By this we are going to store the list even if the head is deleted. So basically in the deletion of head, since we already have a node before it, so this is going to be here as a dummy head for us. Okay, next we'll have logic to remove the element if found, which is going to be this 4 steps: store future, update previous next, delete current, and updates current. Okay, so these are all the simple steps to solve this question. You can see here there's going to be a dummy variable which is going to point to head, and due to this, now head deletion is also a normal case where we are deleting element from the middle. Okay, so there's nothing hard in terms of coding of dummy variable. Okay, I'm going to reuse this same code that we wrote for iterative approach. Okay, because the logic remains the exactly same. It's just on optimization for us. Okay, so this is all simple. Next, I'm going to remove this head case, and I'm going to develop this uh, list node star, or you can write list node dummy of 0. Okay, so this is a dummy node which is storing 0 inside it. You can see the constructor over here that if I wrote something like list node and 0, it's going to store a value 0 and the next pointer to it is going to be null. Okay. And then list, and this is, I'm going to update this. So list node star previous is going to point to dummy, address of dummy. Okay. So hence we are going to write and dummy. Okay. Next, we'll need to connect this dummy to our main linked list. Hence, previous next is equal to head, or you can also write current after this. So these three lines are basically the core setup for a dummy method. Okay. And other than that, there's almost no change in the whole code. The last time that we wrote that current is not equal to null, current going to travel, we also have previous, so it's almost going to remain same. In the end, you can, this is main part where you have to return dummy dot next. Okay, so this is going to basically return the head of our main linked list. Okay, so you can see dummy solves a lot of problem for us because now we don't have to worry about head at all, and this previous is pointing to dummy. So you can see the setup here that previous is pointing to dummy, current is pointing to head, and now head is also a basic case for us. Okay, so same logic is going to delete head as we deleted the middle elements. Okay, so let's run this, and this dummy dot next is going to return this head. Okay, so whatever is connected over here, it does not matter if it's this 6 or it should be this 2 connected over here. So in the end, dummy dot next is going to return this pointer to this one. Okay, so let's run this. Okay, let's submit this. So you can see we have solved this question using all the three approaches. This demo method is very important. Okay, so that's it for this video. Thank you.